What up, mathletes? Woo! All right, here's the warm-up. I have my picture in the middle of the screen, so it's not in the way of this graph for your warm-up. Go ahead and do the warm-up. Pause me and see if you can name the ordered pairs for each point. Ready, set, go. All right, we should be back by now. I need a drink of water. And let's go through this quick. So, looking at the point E, that's on the x-axis. So, it's going to be x equals -4 and 0 on the y. So, that is -4 in the x direction and 0 up in the y direction. F. To get to F, I need to go -5 in the x direction and down 5. So, that's -5, -5. G, 0 in the x, but up 4 in the y. Okay. H is going to go over 1, 2.5, and down 1, 2, 3.5. So, to the right 2.5, and down 3.5. And then for J, we're going to go to the right 3 and up 3. So that's the point 33. Boom. Write those down. Call them good. Are you ready, set, go? Just in case we were right. Were we right? Looks like we were right. Let's go next. All right. Today we're going to talk about functions. Move this out of the way somewhere. Maybe if it loads, right? Okay, I guess I'll move right here. A website that recently looked at 6.3 million selfies posted on a popular social media site found that the most popular city for selfies was London. New York City came in second. The other cities in the top 5 in order were Amsterdam, Paris, and Barcelona. The percent of 6.3 million selfies taken in the 5 most popular cities can be represented by the relationship in the graph. We can analyze the relationship between the dependent and independent variables to determine whether the relation is a function. So I'm going to go over here and let's look. Tap on each. You're not supposed to be showing. All right, so let's look what happened here. It certainly looks like a function. So London is at 14.05% of all the selfies taken, followed by New York at 11.62, Amsterdam at 9.82, tied by Paris, and then a little bit less than that is 9.35 for Barcelona. So we can see that the relationship seems to be that the higher the city is rated, the more selfies there are. The only tie would be between Amsterdam and Paris. Awesome. That relation that we see between them is called a function. Now, functions do have some rules, which we're going to go over, and the first one is the vertical line test. So on your notes, you should write vertical line test, and here's what a vertical line test is. To test graphically if a function is a function, we use the vertical line. The idea being, remember, the rule to be a function is it has to have, for each x input, only one y output. In other words, we don't want to put in an x and get multiple y's out. So if we do this vertical line, as long as it only touches the graph in one spot, we're good. So for this one, f of x equals -2x plus 5, yes, that is a function. No matter where I move this vertical line, it only touches it once. This is a parabola. The last one was a line. This is a parabola. And again, even though it's moving up and down, no matter where I move the screen line, it's only touching once. Now, something to note is, like for instance, right there, we see that our y value is going to be 8 for this x value of about 1. And then again, our y value is 8 again for a different x value. It's okay that different x get the same y, but the same x can't get different y. So it's still a function and only touches one time no matter what I do. Uh-oh, what about this? Well, if I go all the way to this edge right, well, no, yeah, you can't see it, it doesn't do it, but if you went all the way to the edge, it would hit only once. But everywhere else, we're getting 2 possible values of y for each x. which means this is not a function, not a function. Right here, we're going up in a positive direction. Look at that. It's only touching once. That is a function. And last but not least, we have this relation right here. That is not a function because how many times is it touching through? It's touching twice. So, a vertical line test shows us very quickly if something is or isn't a function. Defining a function, I want you to write this down. Write function is a relationship between input and output. In a function, there's exactly one output for each input. In words, a function is a relationship in which each element of the domain is paired with exactly one element in the range. Go ahead and draw these examples right here. And for this graph, at least draw the graph out, label out like it has. You don't need to draw all these grid marks. And then give a loose drawing of this graph. If you want to, graph each of these points, negative 6, 8, right? So, well, you can do negative 3, 5, though. Negative 3 up to 5. Or I guess these are two different functions. I didn't realize that. These are two different functions, so don't necessarily grab it. But both of these do represent a function. If I did a vertical line test at every point, it's only going to hit once. Over here, we see that each x has only one y. There's not multiple arrows coming off of it. That is a function. Have that whole thing written down. And let's go through some examples. Okay, excuse me. So to determine whether each relationship is a function. Well, this is a map, right? We see two different maps here. Well, notice 2 goes to 5. Well, let's look at 3. 3 goes to both 5 and 0. Each input should only have one output. This has multiple outputs, so therefore it is not a function. Over here, let's look. Negative 2 goes to 8. Negative 1 goes to 2. 0 goes to 8. 1 goes to 4. 2 goes to 2. Each one of these x only have one y. Now, is it true that, for example, 2 goes to 2 and negative 1 goes to 2? That's fine. But what we can't have is a situation like over here where 3 goes to both 5 and 0 from the same number. Okay? So this is a function. And we can check those. Excuse me. Let's look down here. So we have our x's. 3 goes to 7, 5 goes to 2, 1 goes to 4, but 1 also goes to 9. Uh-oh. We have an x value that goes to two different y values, right? A 1 goes to 4 and a 1 goes to 9. That's not a function. How about right here? Again, our domain is our x, our range is our y. Negative 4 is 2, negative 3 is 3, 0 is 6, 2 is 8, 5 is 11. Each x, or each domain, has only one range. Each x only has one y, or each input only has one output. Therefore, this is a function. Awesome! Oh, excuse me. Better reset that slide. If I don't do it, I forget later. I go to teach it, and it's all done, and then they see the answers beforehand. We don't want that. I want to analyze some data now. 5 schools are competing in a long jump portion of a track meet. The distances of the players with the best jump on each team are as follows. Team 1 was 20.6 feet. Team 2 was 21.5. Team 3 was 20.9. Team 4 was 19.4, and Team 5 was 20.2 feet. It says, let's make a table. So you can see we have the team number. Team number 1 was 20.6 feet. What was team number 2? 21.5. Team number 3 was 20.9. Team number 4 is 19.4. And team number 5 is 20.2. Boom, we're crushing it. Determine the domain and range. Well, here's the good news. This is the domain. The top's the domain, the team number's the domain, and the range is the jump values. Okay? So for my domain, I have 1, excuse me, 2, 3, 4, and 5. And for my range, I have what? 20.6, 21.5, 20.9, 19.4, and 20.2. Let's close that set off. All right, there we go. Perfect. Sorry, I'm tired. It's the end of my day. I'm a little tired, so please forgive me. But that is our domain and range. Get that written down. I've got to erase it so I can move on to our next part. Part C, determine whether the relationship is a function. Well, let's see. Each x has only one y. Each input has only one output. So yes, this is a function. The answer is this a function? Yes. Oh, excuse me. Awesome. Let's go ahead and move on to our next slide. Says 4x minus y equals 17. Is it a function? Explain your reasoning. Well, I'll tell you very simply. Let's look at this graph right here. Does this graph pass the vertical line test? Yeah, at every stage. It's only going to hit it once. So, my answer would be yes. For each element of the domain, there is only one element in the range. And that's correct. I'm going to reset this though. And that's it for today. So, with that said, peace out. And this will be for tomorrow.